Good afternoon. Uh, my name is Nitin Mahadik and I am working as a chief engineer at Tecnimont. Tecnimont is a multidisciplinary EPC contractors working all around the world, and the projects are spread all over the world with different types of codes, international codes and practices. Uh, we not only design and detail, but we construct and commission the project, and we hand over it to the end users, the client. And this is how makes us very what you call as a full life cycle of the projects we need to do, right from design, conceptualizing, designing, and then detailing and fabrication and even construction, erection. All the life cycle is done in Tecnimont. So as far as Idea Statica is concerned, it helps us design the connection, revisit all our previously done connection, since Tecnimont is having more than 50 years working in this field, and so all other connections which we have designed and standardized, we got this opportunity to redesign it. Then we found that it is more what you call as a optimistic design. Normally we see that the component of the connection is around say 20% to 25% earlier now, but by using this we able to reduce that component to say 15% to 18%. I'm talking about the contribution of connection steel tonnage. If the project is of 20,000 ton, then 50% is a connection component. So that optimization we can achieve by using this Idea Statica or any advanced software. So we'll start one by one. Real life problem we will see. I will give the one example which I am associated with, and the Repsol. The project was situated in Portugal. It is a petrochemical project, which is a PP project, polyethylene and high density polyurethane. So this is the ingredients for the plastic, and our company is having a huge market share in international market. So this particular project is situated in Portugal, Sines, and the complete design detailing is done in our Mumbai office, the main engineering center of Tecnimont in Mumbai. So we'll go over this one by one. This is the project's picture at the erection stage when I was at site. So this is one of the process plant. You can see the multi-zone reactor structure, and this multi-zone reactor structure, which is one of the process plant in the whole plant, you can say, and this is around say 1500 ton almost, the complete steel tonnage. And here we have implemented one philosophy to erect it in a module, like pancake module. You can see the erection is done, the complete floor is erected, and the pancake which is being erected there, which is assembled on the ground with all the beam, column, grating, handrail, ladder, and small miscellaneous equipment, and the complete module is erected in a vertical sling position. So each floor is one pancake, as a pre-assembled module lifted, and this reduces the erection time substantially, and this is being implemented now onwards to all the projects in Tecnimont. So this is not only reduce the time but also the cost component of the erection, and having pre-assembled on the ground, the tightening and bolt all in controlled environment, in a climate, environment, and then it lifted at a correct position. So the splices that we found, there are many issues which we need to address, and at that time Idea Statica rescues us, you can say, that the butt splices we use for column, which facilitate the erection. At the same time, the lifting lug, you can see, I will show you in the next slide, the lifting lug are designed. All the connections have been designed in Idea Statica using their checkbot because the whole structure is designed in SAP 2000 for the global analysis, and using the checkbot facility in IDEA StatiCa, the forces are transmitted to IDEA StatiCa to analyze and design the connections. The vertical bracings we have used here is a circular section which is economical, and those connection which is quite complicated, we design it in IDEA StatiCa to get this complete behavioral check. And at the same time, you can see there are many equipments, many silos are there, and we check these members also in IDEA StatiCa for LTB, lateral torsion buckling, and to analyze the torsion effect of the beam. So this IDEA StatiCa gives a tool where we can check, visualize the things more efficiently, which would have been impossible by formula-based Excel sheet. So that's the main difference. What we found more helpful for any analysis and design of structure. We can go for particularly for the deep beam. You can see the beams here we use is a 1.5 meter deep plate girder with lot of stiffeners, and to check this beam, IDEA StatiCa, I mean, this is a really helpful software for us. So I will go over one by one. You can see this is a pre-assembled module which is assembled on the ground with all those components in place. So this is a global analysis done in SAP 2000, right? And the process structure, you can see the different color codes of each pancake which is being lifted, and this is a lifting analysis of each module. And at the bottom you can see there is a splice, but splice which we use for the entire structure for the column, which helpful to splice it on the spot. And here is a lifting lugs. You can see the lifting lugs. We analyzed in IDEA StatiCa. This lifting lugs is such that they can be reused many times. The splices and the bolt spacing, everything are so customized that we need not to use different lifting lug at each module. So this is how we conceptualize the entire structure in order to get the maximum benefits of IDEA StatiCa and this modular structure, I mean modeling philosophy, which we implemented in this entire life cycle. So this particular workflow which we used to do in Tecnimont is the global analysis, which may be in STAD or SAP. Then we pick it one joint in IDEA StatiCa checkbot. We import all those forces acting at the joint, which is in equilibrium. So, and these are the final connection. You can see there the result of final connections. So one question which I heard that there are many load combinations. We have thousands of load combinations, more than thousands of load combinations, and we import it in IDEA StatiCa. One thing I just wanted to tell you that you have to have a fast processor, maybe 16 GB, and the new, I think from 24 version, they have introduced this critical load combination. They can discard all those non-critical load combination, and only critical load combination they are using. So it is fast comparatively. So this is a workflow which we normally use. Then there are many joint in any structure. Now this is the one structure I have shown you the process plant. There are extrusion building, there are pipe racks. You might have from the same background of as a structural engineer. So there are pipe racks, pipe bridge, repetitive of connections are there. So there is one feature called joint resistance, right, in IDEA StatiCa. So you can find out the capacities of that particular connection, and at the same time, for example, just giving you example, there are a shear connection. You can see different types of shear connection, and shear connection is a shear and axial forces. So the relation is established that for particular shear force, what is the axial capacity, that particular factor we establish and we apply it rather than design again and again the connection. So that benefits you can draw from this particular joint design resistance. This one helpful tip. I mean, then there is a, as Yashwant has already shown you the how we transfer the data to the detailing agency who detail it in Tecla or SDS2. Normally we do it in Tecla because our all downstream activities are done in Tecla. So the detailing company, we used to transfer this file to them, and by sending this file, they need not to have the license, as he explained. They can quickly access this data and implement this connection in Tecla for producing the shop drawings. And this is a fast app. It needs only internet. Similar to that previous structure, this is another structure which is called extrusion building, and which is around 5,000 ton structure, having supported all the major equipments in that. You can see the one of the equipment is perch bin silo at the top of the structure, being almost 800 ton to 1000 ton. And here you can see all the system which supports the equipment is large plate girder, and we specifically use this software idea StatiCa to understand the behavior of the plate girder in a member app of the idea StatiCa. So as explained earlier, that we found all those analysis sequence, and as per the code, the LBA is restricted to the value which is shown as 15 in this particular project, I mean Euro code. At the same time, we check the deflection, LTB, and all those connections and members to ensure that there should not be any adverse effect under the action of earthquake and wind, because which is very difficult to analyze in a global software, even in SAP. So this benefits of idea StatiCa enables us to put the steel at the right place rather than adding the redundancy in the structure or reduce the unused member. So that benefits we are drawing from idea StatiCa. And similarly, the project which is going on in Tecnimont, which is in UAE, where there are different demands from the client to prove it that the LTB, for example, one client has asked us to prove the LTB, means lateral torsion buckling, is properly implemented, or whatever the plan bracing we are giving to break the LTB, break the length of the member is functional or not. So with the idea StatiCa we used to prove this. So that is one help that idea StatiCa always give. I will show you one example how we prove the TQs from the clients. So you can see this is a longitudinal beam which is supported by the column, and there are the cantilever cable trays you can see in between. The beam is 9 meter in length, and there is a lateral restraint of a beam that is idealized as a lateral restraint because plan bracings are not modeled, and we have to prove that the beam is good enough in torsion. At the same time, all the stresses and everything is in order. So we model this in idea StatiCa member with all the connections, and we perform the required checks, deflection check, then MNA, GMNA, and further imperfection we put it, and we prove it that this beam, because this beam is not a one beam, this will be the thousands of beam in the pipe rack. So that was a critical selection for us as a member, HE 400. So that is when we prove to the client that everything is in order. So Idea Statica not only design and help in connection, but some issues which client need more explanation for our to endorse our design is safe. So we can check it in Idea Statica. So that is one of the aspect I find it useful. The joint stiffness, in a global analysis, we presume that everything is rigid, but in actual cases, it is almost semi-rigid. And the correction, sometimes some clients ask to make a correction in a global analysis by taking the semi-rigid condition. So we need to check this stiffness. I remember one project client specifically asked to prove the system is stiff enough, rigid enough, which we assume in a global analysis. And that check we can quickly perform. Otherwise, with the formulas, we will end up in too much of Excel sheets, which doesn't make sense. There are n number of formulas from textbook and manuals. There are a lot of constants, and we find ourselves great by using something, devising something, but it is nothing. This formula doesn't make sense. There are only 3-4 aspects in Idea Statica which gives all the checks, as you can see. As Yashwan has shown that stress, strain, LBA and bolts, these are the checks, and welds, these are the checks we need to perform in Idea Statica. Rest all the code check for the bolts and welds are presented in detailed calculation report. Before implementing this Idea Statica in our company, we verify ourselves with manual design guides or American design guides. Few problem we'll solve it and check it, and we found that it is close to the calculation which presented in the manual. Most of the times Idea Statica is on the optimized side. So the decision whether to use which plates and how to optimize the connection, that is the engineering judgment. So as long as the connection component is within 15%, that is our target always, because we are a contractor, and our target is to restrict the connection tonnage within 15%, unless it is a truss like structure where it goes to almost 20%, but not beyond that. But slowly we are migrating to use this Idea Statica, revamping our earlier standards which develop in Tecnimont, and that is how the things are moving. But as I said, Idea Statica not only design the connection, but the member design aspects of Idea Statica has a very large potential, and it will help us understand the behavior of any member, particularly the large beam, the length, the 10 to 15 meter length girder. We can analyze and make ourselves satisfy whether it is sustain that loads. Particularly when you support huge equipments having more than 500 ton. So it is very complicated for us to understand the behavior or the failure which can be analyzed in Idea Statica. There were many software. There are many software in market like ANSYS we have. But this Idea Statica, what we found is more helpful is that it is customized and it is for the structural engineers. So with 20 operations, we can build the connection and modify the geometry. There is no restriction to the geometry. You can modify the geometry as you can. There are templates out there, as Yashwant explained. There are thousands of templates. You can get yourself influence and use that templates, or you can design the similar connection. Earlier in Tecnimont, we didn't use circular type bracing connection because the analysis is quite complex. But with Idea StatiCa, we are using those profiles for the vertical bracing, because circular section is more economical as for the vertical bracing. Only thing is the connection, but we can design the connection here now with Idea StatiCa to see everything is fine. So in this entire project, all the vertical bracing we use as a circular, and the cost, I mean the tonnage, comes down drastically. Rather than using a I section, HE section or W section for vertical bracing, circular sections are quite economical, not only for a tonnage point of view but connection point of view also. And the welded profiles, I mean the built up profiles, we can model it and check in Idea StatiCa. Let it be the plate girder or gantry girder, you can say, where you can play with it and understand the behavior. So all this facility, or you can explore as many as you can in this software. Just to show you what we are doing to establish the standardization drive which going on in Tecnimont with Idea StatiCa, I will just give you the start where we are starting. So this is the one connection we are using in Idea StatiCa. It is a standard connection in many structure, and there is a star angle vertical bracing to the beam and column junction, and this is a geometry. So we are developing as many as can based on the angle of the bracing to establish the capacities of these connections. And if something is fall beyond this, then we go and redesign the connection and establish another set of capacity table. And this is how we are standardizing. This is something brainstorming is being done in Tecnimont for various connection. This is another type of connection of vertical bracing, same, which is a star angle, and the capacities are estimated based on the given section, the beam profile and the vertical brace. So this is another aspect you can go and standardize your company standards to large extent. At the same time, there is another aspects in Idea StatiCa, which is parametric, which is being explored, and you need not to design every time the connection. You set the parameters and you apply that template, the parametric template, and everything will fall in place in a few clicks. So that is one interesting topic of parametric. So that's all I have. If you have any questions, let me know.
Thank you, Nitin Mahadik. Anybody has any questions? No. Thank you. I think you are really using it in a very efficient way. Not only the connections, looking like even in the whole structure, and you are able to reduce the weight, which is quite quite nice to hear that. And how you are standardizing both for simple and also the complex, able to design complex connections. Thank you, Mr. Nitin Mahadik.
Yeah, thank you, Prasad.
Yeah.